Hello students, today we will learn how to find out critical activities and critical path. Let us consider this example. So activities 1 to 2, 1 to 3 to 2, 3 to 5, etc. And duration in weeks are 15, 15, 3, 5, 8, etc. for these activities. And first of all, we try to develop a network diagram. Okay, how do we start? We take a starting node. We can see here it is 1, and the activity 1 to 2 is emerging from 1, 1 to 3 is emerging from 1, and similarly from 2 activity 3 is emerging, and so on. So 1 to 3, 1 to 2, and then from 2 to 3 is here, to 2 to 3 will be like this, and then you see 2 to 5. So 2 to 5, if I put 5 here inside the circle, then 2 to 5, and then 3 to 4. So 3 is here, so say 3 to 4 is this activity, and then 3 to 6. So 3 to 6 is node 6 is somewhere else here, and then 4 to 6 also, 4 to 6, and similarly 5 to 6, and then 6 to 7. So we put those nodes inside the circles like this, all this, and what we do, we put the activity durations along the arrows, okay, which tells, these arrows tells us, okay, we are going from node 1 to node 3, 3 to 6, 6 to 7, like this. So we have put now these activities along all these arrows. You can see these 6 to 7, 14, say randomly 3 to 6, 3 to 6, it is 12, and 2 to 5, say 2 to 5, it is 5. So these are put like this. So first of all, the first task is construct a valid network diagram. So this is done, right? Second thing is find out earliest start time and latest finish time. So first we go forward, we call it forward path method. So forward pass we say also. So during forward calculations we find e values, that is earliest start times. Okay, so this activities at node 1 to 3 activity at node 1 starts at 0. Okay, and it takes 15 units of time to go to node 3, and similarly activity 1 to 2 is completed also in 15 weeks duration, and similarly all other these activities. So what do we do now? This yes, now 3 to 6, so this is 12 units of time it takes, and it is 15, yes, 15 is this. So if I go from 1 to 2, the earliest start time of activity at this node 2 would be 15 units, and if I go to 2 to 3, if I have to start this activity 2 to 3, so earliest start time would be this, and it takes another 3 units to go to activity 3. So this is 15 plus 3, 18, and from, if I go by this path to node 3, it will be the time would be 15. So we take maximum of the durations along the paths, different paths reaching at the same node, okay, to determine the earliest start time for that node. So here 15 and 18, the maximum is 18, so earliest start time for the activities which are starting from node 3 is 18. Similarly, we go this way, 18 plus 12, it is 30, and to reach at node 6, and if I go by this path, so it is 18 plus 8, 26, and 26 plus 14, it is 40, and if I reach here, 26 plus 1, it is 27, and if we go by this, it will be 20, 15 plus 5, 20. So maximum of durations this and this path will be taken, that is 27. We have to write here early start time for any activity starting with 5 is 27, and you see if 27 plus 3 is 30, so 30, 40 and 30, so maximum is 40. So that will be the other start time for activity starting at node 6, so it is 40 and not 30. So yes, and the last one is 6 to 7, so 40 plus 14, that is 54. So 54 is the start time for any activity which will start at node 7. And yes, what we do now, we find out the latest finish time, so we go backward. Okay, and the earliest start time, latest finish time for the last active node is just same as that of the earliest start time. Okay, so that's why L is 54. Now we go back, so 54 minus 14, that is 40. 40 is the latest finish time for activity at node number 6. So we go back now, so 40 minus 3, 37. Okay, and then this side, if I go, so it is 40 minus 12, and that will be 28 and not 18. So what we do, no, this activity we reach backward through two paths, or rather three paths: one path, two path, and three path, third path. So yes, so now go here, 40 minus 14, 26, and prolong this is 27, 27 minus 1, 26, and then 26 minus 8, that is 18. So 18 and 28. Okay, so it is minimum. We take minimum when any two lines are merging at one node backward. We take the minimum of the durations for computation of latest finish times. So that is 18. Okay, and then go back here to the 7 minus 5, that is 22 along this path, and if we go from here, we can see that now this is 18 minus 3, it is 15. So minimum of 15 and 22, it is 15. So latest finish time for this will be 15. And then from here we go here, and from here we go here. So 15 minus 15, 0, and 18 minus 15, 3. Minimum is 15. Minimum is 0. 3 and 0, minimum 0. So latest finish time for this is 0. So that's how we find out the earliest start times and latest finish times for different nodes, okay, or activities. Okay, and the activities or the nodes for which these earliest start time and latest finish times are same, these are known as critical activities. So we get this path, and now I am putting two arrows, double arrows, in order to signify that this is the critical path. Along this, there are critical activities. So critical activities are those activities, if we delay them, the total project duration will be delayed. So here the total project duration is 54 weeks. So that's why we cannot delay these activities: 1 to 2, 2 to 3, 3 to 4, 4 to 6, and 6 to 7. These are critical activities, and this is the critical path, and this is the total project duration. So this is how we do the computations in critical path method. Okay, so thank you very much.